Welcome to the Math 1, Unit 8, Lesson 8, Summary Video, Rainy Day. This lesson is a practice understanding task which takes concepts you've been working on and applies them to new situations. The purpose of this lesson is to practice solving quadratic equations in different forms, including those that need to be rewritten prior to factoring. If it rains at the fair, the vendors and games have a hard time making a profit. At the turkey leg booth, the profit on a typical day can be modeled by this function, where P of T is the profit in dollars and T is the number of turkey legs sold. And we can see that this equation is written in standard form. And when we look at the last term, the minus 1,300, in terms of this situation, we know that that is where we would find that on the graph would be the y-intercept. And so if P of T represents the profit in dollars, and that's our y-intercept, we know that our function would be crossing the y-axis at negative 13, which means that we would have negative $1,300 profit or no profit. That would be the expense of running the turkey leg booth prior to us selling any turkey legs. So we can see here on the graph, I'm using Desmos to display this, and we can see here on the graph that negative $1,300 located here on our y-intercept. And again, that represents the cost or the expense for supplies, staffing, startup costs, all of that, just to run the booth prior to them even opening and selling any of the turkey legs. A couple other key points and features on this graph. So in Desmos, what I did was I entered the equation, and it's a little bit up above there, you can't really see it, but I entered the equation into Desmos, and then you can convert that to a table, and you can select any x-intercepts you want. And so I typically went by hundreds, but I added a few others in here to help with some of the questions in 1 through 5 in your task. But a couple of key features. If we look at our x-intercepts, what those represent are the number of turkey legs that represent zero profit. And so those would be our break-even points, meaning the expense of the $1,300 is equal to the income for selling 50 turkey legs. Same thing here when we look at 400 zero. If we sell 400 turkey legs, we again have a zero profit. And then we can see down here at 450 turkey legs, we would be back down to negative $1,300. We can see our vertex up here, or our maximum. The maximum that we would need to sell is 225 turkey legs for a maximum profit of $1,990.63. Notice we're going to round that to the nearest hundredth because we're talking about money. So the interval of increase is everywhere from our y-intercept up to our vertex, or from 0 to 225, and our interval of decrease is from 225 really to 400, because after that we're no longer making a profit. We could continue to sell turkey legs, and so our interval of decrease could actually extend beyond 400. We wouldn't want it to do that because the purpose of having the booth is to make money. So any amount of turkey legs that we sell above 50, greater than 50, but less than 225 would be increasing our profit. So from 51 legs up to 224 legs would be increasing our profit up to our maximum profit. Anything from 226 legs down to 400 legs would be decreasing our profit. And so again, our maximum profit occurs there. One of the questions in your tasks asks you, if the booth wants to make a profit of $1,000, approximately how many legs would they need to sell? And so I added in the table here, I added a couple of additional X values. And so we can see in the table, if we sell 101 legs, we would make just under $1,000. And if we sell 102 legs, we would make just over $1,000. And you can see those 2 points are located here on my graph. Additionally, if we're looking at 1,000 and we go over, we see that we hit the function in 2 different places. And so at $1,000, we would make a profit if we sold 102, and we would also make a profit at 300 of approximately $1,000 if we sold 348 legs. So going over to X, over on X to 102 legs and going up, we're going to hit at about 1,000, and going over to 348 and going up, we're going to hit that profit of about 1,000 as well. So for any amount of legs between 102, from 102 legs all the way to 348 legs, so when X is greater than or equal to 102 legs, but less than or equal to 348 legs, we would make at least $1,000 as a profit. The graph below shows the same turkey leg booth, but on a rainy fair day. Since not as many people attend the fair when it's raining, the turkey leg booth doesn't get the same amount of business. So we can see some differences here in the graph that they provided us. So here we can see the x-intercepts are at 20 and 200. And so that's saying that the break-even point is when they sell 20 legs and when they sell 200 legs. And we can also see the vertex at 110 legs, which again represents the maximum profit that they can make. So if they sell 110 legs, they can make a maximum profit of $607.50. So I am using Desmos again to compare the similarities and differences of the 2 functions. And so on the left side of the screen, you can see the equations and the tables, and on the right side, you can see both of the graphs together, one on top of the other. Now, for the rainy day function, you are not given the equation, and it is not the expectation in Math 1 that you derive the equation from the information given. Some of you may be able to do that, and we'll explore that a little bit in the next slide, how you could do that, but it's not required that you be able to do that from this problem. So some of the things that we want to point out are that, remember the blue function is representing the rainy day, and the red function is representing a regular sunny day. So for the rainy day, any number of turkey legs sold less than 20 would result in no profit, versus any number less than 50 on a sunny day would result in no profit. The break-even point for a rainy day would be at 20 legs, and the break-even point for a sunny day would be at 50 legs. Again, we know that there are 2 other break-even points. So on the rainy day, the other x-intercept is the other break-even point, or at 200, and 400 for the sunny day. So for the rainy day, the blue function, any number of legs sold greater than 20 but less than 200 would result in a profit, versus the sunny day, any number greater than 50 but less than 400 would result in a profit. The maximum profit for the rainy day would be the $607.50, versus the maximum profit for the sunny day would be $1,990.63. And when we look at the intervals of increasing and decreasing, we can see that the profit is increasing on the rainy day from 21 legs to 110 legs, versus the sunny day from 51 legs to 224 legs. And then they're losing, we say losing, they're not really losing money, but their profit is decreasing from, on the rainy day, from 111 legs sold to 200 legs sold, and then on the sunny day from 226 legs sold to 400 legs sold. Number 7 asks us to discuss what P of 100 means in context for each day. And so any number that we put in for the value of T, whether it's 100 or 200 or 150, when we're saying P of 150, for instance, we're saying what is the profit if we sell 150 legs? So when we're looking at P of 100, we're saying what is the profit on the rainy day or the sunny day if we sell 100 legs? Number 8 asks us to discuss what P of T is greater than or equal to 500 means in context for each day. So there we're saying P of T, which we know P of T is the profit. So we're looking for parts of the function, each function, where the profit is greater than or equal to $500. And finally, number 9 says the vendors believe that you will always make a higher profit when it's not raining if you sell the same number of turkey legs. Do you think that this is true? And so we know that this is not in fact true, because if we look at the values, at the output values, when the number of turkey legs sold is between 20 and 50, the blue function is actually higher than the red function. So anywhere from 20 to 40, greater than 20, but less than or equal to 74 turkey legs, the rainy day will result in a higher profit. And then from 0 to 20 legs sold, while neither day would result in a profit, the rainy day would actually result in less of a loss. And so we can see that because the Y values are still in the negatives. So if you wanted to try to attempt to write the equation for this function, we can use some information that we already know. So if we start with the quadratic equation or function, if we start with f of t equals a times t squared plus b times t plus c, and we fill in what we know. F of t equals, I know that this is the standard form, what I first wrote. I'm now going to write the factored form of the equation. And I know that the two binomial factors represent my x-intercepts. And so my first x-intercept is at 20, and my second one is at 200. So I know that my binomial factors have to be t minus 20 and t minus 200. So I've used the two of the 3 points that were given to me in the function. Now I'm going to use this other point. So for this point, I know that my t is 110, and my f of t, when t is 110, is 607.5. So I'm going to take my f of t, and I'm going to substitute that in here, and I'm going to take my t value, and I'm going to substitute that in here and in here. So f of t would be 607.5 equals a times 110 minus 20 times 110 minus 200. And now I'm going to simplify. 607.5 equals a times 90 times negative 90, and then 607.5 equals negative 8100a. And then I'm just solving my equation. So I'm dividing both sides by 8100, and I get a equals negative 0.075. So So now that I have my value for a, I can take that and substitute it back in here and rewrite this equation. So when I substitute that back in, I have f of t equals negative 0.075 times t minus 20 times t minus 200. And now when I use the distributive property to change this from the factored form to the standard form, I have f of t equals negative 0.075 times t squared. I'm distributing the t to the t and the t to the negative 200. And then the negative 20 to the t and the negative 20 to the negative 200. And so I end up with t squared minus 220t plus 4,000. And now when I distribute this negative 0.075 to each of the three terms, I end up with f of t equals negative 0.075 t squared plus 16.5 t minus 300. And so that's how we can acquire the equation, the standard form of the equation for this function.